Okay, so hello everyone. Good morning. Can you hear me?
Yes,
Yes,
sir.
Okay, thank Okay, so we are waiting 1 minute for joining. Then we'll start.
Gochi gochi na loco loco go. Ujarai, 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 ninai.
Okay, so we'll start now for our today's session. So basically today is our fourth number of class, and mainly today I try to discuss about some advanced topic on Google Earth Engine. So let's go. Just I simply share my screen. Can you see my screen now?
Yes.
So basically today I try to discuss about that how we can easily remove the cloud and haze from our satellite imagery, mainly Landsat and Sentinel imagery. How we can easily remove and cloud and haze from the satellite imagery and then get the very clear satellite imagery from here. As well as we also talk about the DEM data, NASA SRTM DEM or STAR DEM. So this type of DEM, how we can easily use, and then how we can easily create the hillshade map, slope map, aspect map using Google Earth Engine platform. As well as we also talk about the LST monitoring, land surface temperature from Landsat satellite imagery, and also time series chart. Previous class we talk about the MODIS. So today's session we talk about the Landsat satellite imagery, how we can easily use and then make the LST map and also time series chart, and how to calculate average, maximum, minimum NDVI for any specific region. We try to discuss about that, as well as we also talk about the monthly time series chart. So mainly how we can easily create the monthly time series chart. In this time, I choose the example for evapotranspiration. How we will create the monthly evapotranspiration time series chart. So let's go on by one. We try to discuss. So just simply open my slide. Okay, so first of all, here you can see this is the one kind of land surface temperature mapping. So basically, in this time, we are using the Landsat imagery. So that's why you can easily get the better map. But when you want to use the MODIS satellite imagery for the small region or small boundary, then we did not get the better result because this pixel area is very high. This pixel area is 1000 meter. But in this time, for the small region, then when you have to use the Google Landsat satellite imagery, then we can get the better image, better land LST map, because this pixel area is only for the 30 meter. So that's why we can get the very better map for the small region. But when you want to apply the MODIS is okay for the big region. Okay, but for the small region, it's better to use the Landsat imagery because it's pixel area is low. And we also talk about that assessment of the urban heat island, how we can easily calculate the urban heat island using Google Earth Engine platform. These things we also try to discuss. And we talk about that urban thermal field variance index using Landsat imagery in Google Earth Engine, mainly UTF-VI. So it's the urban thermal field variance index. And we talk about that, suppose how we can remove the cloud using the cloud max function. Suppose here you can see we can get this type of cloud. Okay, but when I apply the cloud max function, then we can get the very clear satellite imagery. And then we can easily use it for the different types of analysis. As well as we talk about that DEM data. So basically using the DEM data, how we can easily create the elevation map or hill shade map, slope map, aspect map, and how to calculate average, maximum, minimum NDVI in a specific region. So let's go ahead and start one by one. So just I simply open my code editor. So just I open a new code editor and I try to open the Evapotranspiration data set from here. Suppose Modis. And I try to open this data from here. Modis Evapotranspiration. Okay, you can see it's a 8-day. Okay, so in this time, this 8-day data set, I want to convert into suppose annual. Okay, annual. I want to convert it annual. This data set. So how I can do that? And this data set is available from the year of 2001 to 2024. I want to need the annual data set. It show the 8-day. When I want to use the data set and make the time series chart, I can get the result in 8 days interval, every 8 days interval. But when I want to convert it annual, then I can get the annual. Every year, what is the average value for evapotranspiration? So let's go try to discuss about that. So just I simply copy and then paste here and then give a variable name, suppose data set. Okay. So now this data set, I simply select the specific band about this data set because this data set have a some band. I want to work for the total evapotranspiration, mainly ET. Copy that and paste here. Okay. And I want to make this time series chart for that. Okay. So in this time, I want to make the annual time series chart. So for that, I just use the same approach which I should use in here. So just I simply copy. I simply copy from here. Start here and in here. Simply copy and paste here. Okay. So I define the time period. Suppose year of 2005 to 2023. Okay. So I define this time period. Start here and in here. Further, I just simply make the sequence. Suppose I simply put the sequence, this sequence. Sequence mainly it's one kind of list about your annual list. So put here, you can see when I print that about the years, click to the run, it show the list about that 19 years. You can see, click on here, you can get the 2005, 2006 and up to 2023. So this is my annual list. I want to calculate the average evapotranspiration for each year. Okay, so let's go try to use the code in here. So here you can see I just copy the same code from here and then further I paste. Okay, so in this time annual precipitation, I simply put it, it's a annual evapotranspiration, or you can put any name as a variable. So in this time image collection, this function you have to use, and years I already defined the years. You can say I already defined the years, and annual is a variable name. I call my data set. So in this time, what is my data set? This is my data set. This is my data set. I just paste in here this data set. Okay, and then filter. I want to filter it annually, annual to annual, year to year. Okay, year to year I simply filter it. So put here year to year, and I want to calculate it the average, not total. I want to calculate it the mean evapotranspiration, and return annual set same. So now you can see when I print that. So print that annual evapotranspiration, simply copy and paste here, click to the run. So now it create the image collection for 19 years between 2005 to 2023. So click on here and you can see about that feature. So in this time, okay, in this time here you can see we can get the image from 2021. Also you can see the image 2022, image 2023. Okay, let me check about the data set. It's available 2000, okay, 01 to 2024. Okay, suppose I put at the year of 2020. You also try to another data set about that. So we can get the 4 years. And in these 4 years, we can get, we can show the data set only for the year of 2021. Okay, we try to make the chart for 2021. You also try to check the other data set, what happened, it show or not. In this time, it calculated 3 years. You can see it's the 2021, then 2020, and 2023. Okay. Okay, so now we try to make this chart for that, whatever you can check. Suppose I just copy that same code from here. Simply copy and paste. Okay. So now, okay. So now we simply call this annual evapotranspiration and paste here. Calculate the mean region. So you can simply set your region. Suppose I simply import my shapefile is the Dhaka city and put here that ROI. Okay. And then further just put the region is that ROI. Okay, so I put the band name mainly ET, evapotranspiration, and also put the resolution 500 meter. This data resolution is the 500 meter. So just put here the 500 meter, and it's also okay. So now I want to set option. Yeah, it's not there. Remove that. I want to add the later. So now click on. And further, you also print that. So just print this. So print the chart in one. Simply copy and paste. Okay. So here you can see now it show the annual average value about that. You can get the 2021, 2022, and you can see about that 2023. Okay. So it's a process about that. So any data set, suppose you can get the lot of data set, it's the 8 day, some data set is the 16 day or 32 day, or any data set. When you want to convert, suppose you have a 8 day data set, but you want to need the annual time series chart about this data set. So just simply convert according this way, and then you can easily do it. Okay. Suppose in this time I want to calculate the monthly, suppose each month, each year for each month, January to December, all of those my month I want to calculate. So for that same approach, suppose you can see, I just simply copy the same code from here. I just make the month list. Suppose January, December, make a list with month, and then you just write in here for the month. Simply paste in here, and then just try to add these things from here. Simply copy from here. In this way, calculate the monthly evapotranspiration. So I put here that is monthly, suppose ET, evapotranspiration. Okay, and I want to calculate the years. I already defined the years. Month, I already defined the month, January, December. Okay, I want to calculate it that mainly mean or average evapotranspiration. Okay, so now try to print that. Suppose I just simply use the print function and call the monthly ET and paste here. So now we can check what happened. Okay, we have to change it also because it's charts, but I want to make this data set. So simply copy the data set and use the data set in here. Click to the run. So now it creates the monthly image collection for 3 years, mainly 12 into 3, 36 years. Okay, because 3 years, we can get the total 36 months. So now it converted as a monthly. You can check from here, you can see. Okay, you can see we can get it's a monthly. So now I want to make this time series chart for the monthly and then check about the what is the condition about the evapotranspiration for the monthly. So for doing these things, we are just use the same code in here. You can see I just simply copy this chart from here and then copy these things from here and paste in here. Yes. So now I simply call this monthly ET, mainly monthly evapotranspiration, and region is mainly my Dhaka city, which is ROI. I have to calculate the mean and band name mainly ET. Okay, band name is mainly ET. So put here the ET, scale mainly 500-meter resolution. Okay, and then other thing is okay. So just I remove the set option. I add the later. It's not mandatory. So now I will try to print this chart. So just print and then call this chart monthly. Simply copy and paste it. So now it calculate make the another time series chart for each year monthly. What is the condition about the evapotranspiration? Or you can see you can get this result. So you can see the January, then February, then March, then April, then May, June. Okay, so each year you can get all of those things from here. You can also download the data also from here. Okay, and then you can easily get this result. So basically this is the process to convert the different interval, convert it to monthly or annual. Okay, so basically different types of research work, we have to need the different types of time series interval chart. So for that we are just apply this type of technique, image collection from image, and then we can easily convert from the monthly or annually image collection and we can easily get the result. Okay, and when you to visualize this result, just you just make the reducer and then you can show the result about that. For the visualization, suppose I want to make the total 3 years, I want to make the result visualization of my map. So for that what can I do? Just I make the reducer. Suppose I just take a variable, suppose ET VIS. Okay, and then I just simply call my annual image collection. Basically it's a annual image collection, annual evapotranspiration. I simply call and then I reduce it. So just paste in here and put here the reduce. How I can reduce? Earth engine reducer dot mean. Okay, so now I want to visualize and clip with my study area. So use here the dot clip, mainly ROI. So now I show the result. So just use here map dot add layer, mainly ETVs. Simply copy and paste, and also focus the center of the shapefile. Map dot center object. Object is mainly ROI. Zoom level suppose 10, and then click run. So now it also visualize our evapotranspiration map. Okay, so in this time we can get this type of map. You can see for the Dhaka city, basically it's a lot of build up area, so that's why you can get this type of result, evapotranspiration. So just I simply stressing 98%, and further I try to add the color. Suppose I want to show this type of color yellow, then put here this type of green color. Suppose put this type of green color. Okay, and then apply. So now you can easily get this type of things from here. You can see. So basically, where is the vegetation is the high, where is the vegetation level is high, where we find out the evapotranspiration is the also high. Okay, you can see in this time This type of green color identify about the high vegetation area. High vegetation area indicating the high evapotranspiration, and low vegetation area identify about that low evapotranspiration. And where there is no trees, mainly where there is no vegetation, no trees, so there is no data set. But where you can see about that, it also look more better when you want to work with for any forest or any suppose I show you the example for that another region. Suppose I simply remove the this ROI, I take the new ROI in the forest region, then you can get the more better idea about the evapotranspiration. Suppose it is the mangrove forest, so just I simply click on here and draw my study area. Suppose it's my study area in the mangrove forest. Okay, so in this time we can easily get this evapotranspiration, where is the high, where is the low. Okay, and we can easily get the different types of analysis. So I put the name as a ROI. So ROI. So now click the run. So now we can get this evapotranspiration map for this study area, and we can easily identify what is the condition for the forest. So it look like that. And this result show for that annually. Okay, annual result we can get. Suppose I just try to add in here, and then 98% stressing at the plated. Suppose low evapotranspiration show this type of color, and then medium suppose this type of yellow color, and high I want to show this type of green color, and apply. So now it indicating the high evapotranspiration show as a green color. So here you can see we can get this type of things. So basically this type of green pixel, here you can see this type of green pixel identify about that high evapotranspiration region. Okay. Yellow, blue is the low, yellow is the medium level evapotranspiration. And there's a lot of research paper you can also find out using the evapotranspiration. Actually, it's a lot of uses for the evapotranspiration, for the crop health monitoring or forest monitoring. There's a lot of use for the evapotranspiration. Okay, so this is the way for the visualizing about the data. And if you want to show about the monthly, suppose you want to show the monthly, so for that you can simply call the monthly image collection. Suppose you can see the monthly, I simply copy the monthly image collection, and this monthly image collection I just simply reduce and then click to the run. Yeah, we can get in this time. So in this time it make this map for total all of 36 month. Okay, so 36. So now I can easily add the color. Suppose click on here, stressing 98%. Add the plated. Suppose I want to show this type of color for low evapotranspiration, then this type of color for medium, and this type of color for high. So now I apply. So now I can get this type of map about that. Okay, green pixel identify about that high evapotranspiration. This type of green, it indicating the high evapotranspiration. You want to check the value. Suppose click on here, we can get the value look like that, 295. Okay, and this unit is that you can see this unit is that this initial result is the kg per meter square per in this time per month, because this 8-day we convert into monthly. Okay, so in this time this value we can get look like that. You can see we can get this type of value 295. Okay, so it's a monthly. Okay, so in this time this unit will be kg per meter square per month, because 8-day we convert into monthly and then create this type of map. So that's why it show the result in the monthly 295. When you want for the 8-day, then this value is also low, because in this time we make the result for monthly. So that's why you can get the 295 for month, per month 295. And this type of reason is also low. We can get the low value. This type of color we can get the 143. Yellow is the medium, 241. So this is the process about the evapotranspiration. You also read some other paper, then you can get a lot of idea about the evapotranspiration, how it will work. Okay, And this is the process for making the time series chart annual and monthly. So using this process, not only for the evapotranspiration, any kind of data set, it can be NDVI, it can be EVI, or it can be gross primary production, or any data set in Google Earth Engine, you can easily convert. Suppose monthly, annual, this total you can easily convert. Suppose you can see this is the one kind of data set 8D, leaf area index. You can easily convert into monthly or annual data set. Simply just apply the same process. Okay, so you also try further. You can see the 16-day. This is the 16-day global data set. You can easily convert into 30 days interval or annual interval. Same approach, same process. You also try. Okay, so all of things will be same process. You also try. Also, you can see it show the global LST for global data set, daily global data set. This daily global data set you can easily convert into monthly or annual. Okay, it show the 8-day LST data set. You can easily convert it into monthly or annual, and then you can easily get the result. You can also check about the figure or time series chart about that. Okay, so you also try, and I also give you some assignment regarding this topic. You also try to that. Okay, so I take the question. Okay, but some region, suppose in this time, we have two project, maybe 15 years come from 2024. Some data set have some missing value. Okay, some data set is not available for the whole world. So that's why it's not possible to come for that all time. Suppose you can check some satellite image is not available some region. Okay, so that's why it's not, but other region is, it can be also available. Okay. Okay, so you have to know about the what is the evapotranspiration. Okay, so evapotranspiration is only happen for that trees or vegetation area. Okay, suppose only vegetation area, you can see what is the evapotranspiration. I simply search on the Google evapotranspiration. So here you can see the evapotranspiration is including the water evapotranspiration into the atmosphere from the soil surface, evapotranspiration from the calivary rings, the groundwater table. So in this time, where there is no water, where there is no soil, where there is no any types of vegetation, then the evapotranspiration does not work. In the Dhaka city, maximum region have a totally settlement. Okay, settlement mainly build up area. So that's why it's not fully covered. And evapotranspiration is only include the water evaporation into the atmosphere from the soil surface, or also evapotranspiration by freeze or transpiration of leaf. So this type of things is only possible for the evapotranspiration. And other things, suppose as a settlement or build up area cannot be capable to the evaporate the water. So that's why in the Dhaka city we find out the maximum all of a region. We find out that uh, build up area. So that's why it not completed the full figure. Actually, there is no evapotranspiration for that build up area or settlement. But for the vegetation region, we find out this type of value for evapotranspiration. Okay, so any question about that? Okay, so you also further more study about that, and further if you arise any question, all time you can chat in our WhatsApp group. Also, you can chat in our Google Classroom. When you face any confusion or anything, you can also contact. Okay. Okay, so you also try to practice, and further face any problem, then let me know. And in the meantime, I'll also send you all of those practice code, and also send you all of those recorded class. So you also try to practice. Okay. So today is no more, and next Friday, inshallah, we'll meet at the same time, and then we try to discuss about that. Okay.
Thank you, sir.
Okay. Okay. Have a good day. Okay. Bye.
Thank you.